In this module, we will look at the automatic flight control system. We will start out with a brief system description, followed by a look at the flight guidance control panel and a discussion of each subsystem, including the flight guidance modules, the flight director, the autopilot system, and the yaw damper systems. The automatic flight control system, called the AFCS, encompasses the flight director system, the autopilot, automatic pitch trim, and the yaw damper system. The automatic flight control system includes a dual flight director system, a single autopilot, and a single yaw damper. The automatic flight control system gives the aircraft an all-weather approach capability down to a Category 1 and 2 instrument landing system minimums. The automatic flight control system can also fly very high-frequency omni-range approaches, called VOR approaches, front and back course localizer approaches, and FMS approaches. The automatic flight control system consists of the Flight Guidance Control Panel, or FGCP, the Flight Guidance Modules, or FGM, the Yaw Damper Actuator Unit, and the Autopilot Actuator Units. The heart of the automatic flight control system consists of two independent flight guidance channels. The channels are identical, and each channel consists of a flight guidance module. The flight guidance module processes the flight director commands, the commands to the autopilot and yaw damper actuators, and the commands to the pitch trim system. Each flight guidance module processes the flight director commands independent of each other. The flight guidance modules calculate pitch and roll commands. Autopilot and yaw damper functions require both flight guidance modules. FGM-1 supplies the commands to the autopilot and yaw damper actuators, and FGM-2 monitors the commands and the performance of these actuators. The flight guidance modules are controlled by the Flight Guidance Control Panel. The Flight Guidance Control Panel is at the center of the glare shield. It provides the selections for vertical and lateral flight director modes. This panel is used to select the desired flight director modes and targets, the navigation source for the flight director, and engagement of the autopilot and yaw damper. The mode of operation and the status of the automatic flight control system is continuously displayed in the Flight Mode Annunciator area of the primary flight display. The Flight Mode Annunciator displays the status information for the autopilot, yaw damper, armed and active lateral and vertical modes, and system-related messages. The flight director modes include active and armed modes. An active flight director mode provides guidance for display on the Flight Mode Annunciator of the primary flight display and for coupling to the autopilot. An armed mode is waiting for certain required conditions to be met, at which time it transitions automatically to an active mode. The transition to the active mode replaces the previous mode for that axis. The indication of capture mode is the appearance of an asterisk at the end of the mode display. An armed lateral mode annunciation on the Flight Mode Annunciator is white. Lateral mode armed messages possible for display are VOR, localizer, VOR approach, and back course. A change from an armed lateral mode to an active lateral mode results in a Flight Mode Annunciator green reverse video display for 5 seconds, then a normal green display of the active mode message. The messages listed above for an armed mode are the lateral modes that have the green asterisk and changes to green during capture. The active lateral modes for display on the Flight Mode Annunciator, other than those in capture mode, are roll hold, wings level, heading hold, heading select, VOR, VOR overstation, VOR approach overstation, back course, LNAV, LNAV heading select, LNAV heading intercept, and localizer. An armed vertical mode annunciation on the Flight Mode Annunciator is also displayed in white. White means armed. The vertical display area on the Flight Mode Annunciator has a left and right side column. Alternate select displays on the left side, and glide slope and VNAV in the FMS operation display on the right side. Engagement of a vertical mode results in a green reverse video for 5 seconds, followed by normal green video. The vertical modes that may capture and display the asterisk for capture are altitude capture, glide slope, EL, and VNAV altitude capture. The other vertical modes that display on the Flight Mode Annunciator are pitch hold, indicated airspeed, vertical speed, altitude, VNAV path, VNAV altitude, go around, glide slope, EL, and VNAV FLC. An active indicated airspeed display value is shown with green digital knots on the right side. The digits become white dashes when the tactile control steering is active. The vertical speed displays as vertical speed in green with increments of 100 feet per minute in the same location on the flight mode annunciator as the indicated airspeed. A plus or minus mark precedes the vertical speed digital display to indicate climb or descent. The horizontal situation indicator select push button determines which primary flight display sensors are coupled to the flight director. The primary flight display sensors include the nav source, selected heading, selected source, and the selected air data computer and AHRS. The horizontal situation indicator selection defaults to the left side when the aircraft is first powered. Click on the horizontal situation indicator select push button to continue. Pressing the horizontal situation indicator select push button switches the left source to those selected on the co-pilot's primary flight display and vice versa. Pressing the horizontal situation indicator select push button switches the air data computer AHRS data displayed on the left primary flight display to the air data computer AHRS data displayed on the right primary flight display and vice versa. The selected side is indicated by the illumination of the corresponding arrow next to the horizontal situation indicator select push button. The selected side is also indicated on the non-selected primary flight display. The non-selected primary flight display displays a green triangle and horizontal situation indicator in the above right corner of the electronic attitude direction indicator, pointing toward the active horizontal situation indicator side. Pressing the horizontal situation indicator select push button clears all active and armed lateral and vertical flight director modes if the autopilot is not engaged, and activates the lateral and vertical basic modes if the autopilot is engaged. The flight director bars are removed from view when the autopilot is not engaged and the horizontal situation indicator select push button is pushed. Pressing the standby push button clears all active and armed, lateral and vertical, flight director modes when the autopilot is not engaged. If the autopilot is engaged, pushing the standby push button clears all armed and active lateral and vertical flight director modes. If the autopilot is engaged, the flight director bars remain in basic mode. The nav source switch is used to select nav aids for the corresponding navigation display and for use by the flight director modes. The selected nav aid displays as FMS1, FMS2, or VOR Localizer 1, VOR Localizer 2, depending on the selected source, on the related primary flight display and multifunction display screens. The default nav aid selection after power-up is VOR Localizer 1 for the left side and VOR Localizer 2 for the right side. There are two rotary switches on the engine and system integrated display control panel that control the AHRS or air data computer sources for the primary flight displays. Each switch has three positions: 1, normal, and 2. Having the EFIS attitude heading source switch is in the normal position, the left primary flight display displays attitude and heading data from AHRS 1, and the right primary flight display displays attitude and heading data from AHRS 2. Having the EFIS attitude heading source switch in the 1 position causes both left and right primary flight displays to display attitude and heading information from AHRS 1. Having the EFIS attitude heading source switch in position 2 causes both left and right primary flight displays to display attitude and heading data from AHRS 2. A selection of the 1 or 2 position results in an amber message of attitude 1 heading 1 or attitude 2 heading 2 displaying on both primary flight displays and multifunction displays nav pages. Similarly, if the EFIS air data computer source switch is in the normal position, the left primary flight display will display data from ADC1 and the right primary flight display will display data from ADC2. Having the EFIS air data computer source switch in position 1 causes both the left and right primary flight displays to display data from ADC1. Having the EFIS air data computer source switch in position 2 causes both the left and right primary flight displays to display data from ADC2. A selection of the number 1 or number 2 switch positions will cause an amber ADC1 or ADC2 message to display on both primary flight displays and multifunction displays nav pages. The selection of the AHRS and air data computer sources affects the flight director system. Changing the AHRS or air data computer source selection has no effect on autopilot or yaw damper engagement. However, a change in source will clear all active lateral and vertical flight director modes if the autopilot is not engaged. If the autopilot is engaged, the lateral and vertical basic modes will activate. The flight guidance module takes into consideration the pitch and roll commands selected by the crew as well as the current pitch and roll information. It then calculates the pitch and roll targets. These targets are indicated on the primary flight displays by the flight director bars. When operating with the flight directors only, the master flight guidance module drives the flight director command bars. When the autopilot is controlling the aircraft, FGM-1 provides the commands to the pitch and roll autopilot actuators as well as the yaw damper actuator. FGM-2 simply verifies the information from FGM-1 and confirms that the actuators are responding as ordered by FGM-1. The two autopilot actuator units consist of a rotary servo motor and a capstan. When the autopilot is engaged, it positions the control columns and control wheels through cables. The servo motors turn the pitch and roll capstans to operate the elevators and ailerons using cables. The automatic flight control system operates when the indicated airspeed is between 1.2 vstall and 290 knots IAS, the aircraft's altitude is between 0 and 27,000 feet, and the decision height is 100 feet for Cat 2 approaches. Engagement of the autopilot is inhibited when the aircraft roll attitude is greater than 45 degrees or the aircraft pitch attitude exceeds 20 degrees. If the autopilot is engaged, it will automatically disengage when the roll angle exceeds 50 degrees or the pitch attitude exceeds 25 degrees. Engaging the autopilot automatically engages the yaw damper, but the yaw damper can be engaged without engaging the autopilot. Engagement of the yaw damper is inhibited when the aircraft roll is greater than 45 degrees. Prior to the engagement of the autopilot, the automatic flight control system automatically synchronizes with the existing aircraft pitch and roll attitude in order to minimize any transient input into the control surfaces. Autopilot performance is optimized only for flap settings between 0 and 15 degrees. Autopilot performance may be degraded for 35 degrees flap. However, the autopilot does not automatically disengage if the flaps are set to 35 degrees. The flight director provides aircraft lateral and vertical commands that are displayed on the primary flight displays. The flight directors are coupled to the autopilot for automatic flight operations. The flight directors function in a master-slave arrangement. Normally, FGM-1 is the master and FGM-2 is the slave, and FGM-2 slaves to the mode selected on FGM-1. FGM-2 automatically becomes the master in the event FGM-1 fails. Lateral and vertical guidance modes can be selected when at least one flight guidance module is available. Only FGM-1 can command the autopilot actuators. However, if either flight guidance module fails, the autopilot automatically disengages and will not re-engage. The left or right flight director failure message will display on the primary flight displays. If both flight directors are disabled due to failure of both flight guidance modules, the primary flight displays will display an automatic flight control system failure message. Vertical and lateral flight director modes are selected on the flight guidance control panel. The go-around mode is selected by activation of either go-around switch in the outboard sides of the power lever handles. Both flight guidance modules receive inputs from the flight guidance control panel and the go-around switches. Flight director modes consist of an active and armed mode. Active modes supply guidance information on the primary flight display and to the autopilot. An armed mode is a standby mode that will become an active mode when the necessary conditions are met. For example, the flight director might be in the heading mode, and the VOR mode is the armed mode. When the aircraft reaches the VOR navigation capture point, the system will turn to intercept the desired radial, and the VOR mode becomes the active mode. Both flight guidance modules supply pitch and roll commands through the flight director bars on the primary flight display. The active and armed pitch and roll modes display on the flight mode annunciator area at the top section of the primary flight display. Messages associated with the automatic flight control system are displayed in the flight mode annunciator area as well. Normally, both primary flight displays display the flight director command bars and mode annunciations from the master flight guidance module. Therefore, if both flight guidance modules are operational, both primary flight displays will display data from FGM-1. In the event of a failure of FGM-1, the primary flight displays will automatically display data from FGM-2. The flight director commands are displayed in either a single queue or dual queue format, also known as a crossbar pointer format. The method of display is set in the aircraft configuration module. The flight directors have a vertical, a lateral, and a combined mode. The vertical modes consist of the pitch hold mode, the altitude hold mode, the indicated airspeed mode, the vertical speed mode, and an optional FMS VNAV mode. The pitch hold mode is the default mode when the flight director is turned on. In this mode, the flight director holds a pitch attitude target. The pitch attitude target is initially set to the aircraft pitch attitude that exists when the pitch hold mode is activated. The pitch attitude target can then be modified by manual rotation of the pitch thumbwheel located on the flight guidance control panel. The pitch hold mode is activated when the autopilot is engaged with no active vertical mode, when an active vertical mode is deselected, or when the pitch thumbwheel is rotated and the active vertical mode is not vertical speed, indicated airspeed, or go-around. In addition, a failure of another vertical mode will cause the flight directors to default to the pitch hold mode. The selection of a lateral mode without a vertical mode will also cause the flight director to default to the pitch hold mode. Selecting standby or horizontal situation indicator select, or changing the air data computer or AHRS source will also cause the flight director to default to the pitch hold mode. The pitch hold mode is deactivated by selecting another vertical mode, disengaging the autopilot when the lateral basic mode is active, selecting standby or horizontal situation indicator select when autopilot is not engaged, or changing the air data computer or AHRS source when the autopilot is not engaged. The flight director altitude select mode captures and holds a selected altitude. The mode requires dialing a target altitude using the altitude rotary knob on the flight guidance control panel and pressing the altitude select button at the bottom of the vertical mode's push buttons. The action arms the mode and displays a white altitude select at the upper right of the flight mode annunciator above the displayed digital altitude selection. As the aircraft approaches the selected altitude, the flight director automatically transitions to the altitude capture mode. Stabilized in the capture mode at the selected altitude, the flight director automatically transitions to the altitude hold mode. Disarming of the altitude select mode occurs with deselection of the altitude select switch, transitioning to an altitude capture or hold mode, attaining glide slope or elevation capture, engagement of a go-around mode, switching source selection of the air data computer or AHRS, or activating the standby or horizontal situation indicator select switches on the flight guidance control panel. In the altitude hold mode, the flight director will hold an altitude. The mode is engaged by selecting an automatic altitude capture using the altitude select mode or pressing the altitude button. Activating the altitude hold mode using the altitude push button, the altitude target becomes the aircraft altitude existing at the time of the activation, rounded to the nearest 100 feet. Press the altitude button to select altitude hold mode. The altitude hold mode is deactivated by deselecting altitude, transitioning to VNAV, glide slope capture, or elevation capture mode, or activating any other vertical mode. Changing the selected source for the air data computer or AHRS also deactivates this mode. In the indicated airspeed mode, the flight director will provide commands to maintain a target indicated airspeed. The target airspeed is initially set to the aircraft indicated airspeed that existed when this mode is activated. The indicated airspeed target can then be modified by manual rotation of the pitch thumbwheel located on the flight guidance control panel. The indicated airspeed target can also be modified using the tactile control steering function. The indicated airspeed target is set to the aircraft's indicated airspeed, which exists when the tactile control steering switch is released, rounded to the nearest knot. The indicated airspeed mode is activated by selecting indicated airspeed on the flight guidance control panel. The mode is deactivated by deselecting indicated airspeed or activating any other vertical mode. Selecting standby or horizontal situation indicator select or changing the selected air data computer or AHRS source will also deactivate this mode. In the vertical speed mode, the flight director system will hold a selected vertical speed. The vertical speed target is initially set to the vertical speed that existed when the vertical speed mode was activated, rounded to the nearest 100 feet per minute. The vertical speed mode is activated by pressing the vertical speed button on the flight guidance control panel. The target vertical speed can be modified by rotation of the pitch thumbwheel. The vertical speed mode is deactivated by deselecting the vertical speed button or activating any other vertical mode. As for the other modes, selecting standby or horizontal situation indicator select or changing the selected air data computer or AHRS source will also deactivate this mode. The VNAV mode is available only if an optional FMS is installed on the aircraft. The VNAV mode is only active when the LNAV mode is also active. The VNAV mode acquires and holds a vertical flight path computed by the FMS. The VNAV mode is selected by selecting FMS as the navigation source and pressing the mode selectors for NAV and VNAV. This engages the LNAV mode and arms the VNAV mode. The vertical mode that is active at the time VNAV is pressed remains active until the VNAV capture point. The VNAV mode is disarmed by deselecting NAV or VNAV, selecting a lateral mode other than LNAV, or by selecting Go Around. Changing the selected NAV source, selecting Standby or Horizontal Situation Indicator Select, or changing the selected Air Data Computer or AHARS source also disarms this mode. Operating the pitch thumb wheel or activating any other vertical mode also deactivates the VNAV mode. The lateral modes include the lateral basic mode, the heading select mode, the VOR mode, the VOR approach mode, the localizer, and the back course localizer modes, and the FMS LNAV mode. The lateral basic mode has three modes: the roll hold submode, the wings level submode, and the heading hold submode. In the roll hold submode, the flight director provides commands to maintain the bank angle that existed at the moment of engagement, or when the tactile control steering switch was released with the bank angle greater than 6 degrees. The roll hold submode will maintain bank angles up to 45 degrees. In the wings level submode, the flight director provides commands to hold wings level. In the heading hold submode, the flight director provides commands to maintain the heading that existed at the time the submode was engaged. Flight director commands are limited to 13 degrees of bank angle. A failure of heading data from the selected AHARS will automatically disable the heading hold submode. The lateral basic mode is inhibited by a failure of calibrated airspeed or true airspeed data from the selected air data computer, or a failure of attitude data from the selected AHARS. Both of these events will disengage the flight director. The lateral basic mode is activated if the autopilot or a vertical flight director mode is engaged when no lateral mode is active. This mode is also activated in the wings level submode when the go-around mode is selected. In the go-around mode, the lateral basic mode submode automatically transitions to the wings level mode until another lateral mode is selected or until tactile control steering is operated and released with a roll angle greater than 6 degrees. The lateral basic mode is deactivated by selecting any other lateral mode, disengaging the autopilot when the pitch hold mode is active, or by selecting Standby or Horizontal Situation Indicator Select when the autopilot is not engaged. The lateral basic mode automatically disengages if the air data computer or AHARS source is changed and the autopilot is not engaged. The heading select mode holds a heading target selected on the flight guidance control panel. The desired heading is selected by the two heading knobs on the flight guidance control panel. The Horizontal Situation Indicator Select push button determines which heading selection the flight director system will use. The heading select mode is activated by selecting heading on the flight guidance control panel or when nav, approach, or back course is selected on the panel. These selections arm the associated system. In the heading select mode, the flight director commands are limited to 24 degrees of roll and a 4 degrees per second roll rate. The heading select mode is deactivated by deselecting heading on the flight guidance control panel or by selecting any other lateral mode, a manual selection, or the automatic capture occurrence. The mode is also deactivated when Standby or Horizontal Situation Indicator Select is selected. It also automatically deactivates when the air data computer or AHARS source is changed. The heading select mode deactivates and is inhibited from further activation by 4 possible failures. The first is a failure of heading data from the selected AHARS. The second is a failure of the selected heading input from the flight guidance control panel. The third is a failure of calibrated airspeed or true airspeed data from the selected air data computer. And the last is a failure of attitude data from the selected AHARS. The last 2 failures also cause the flight director to disengage. The VOR mode is used to track a VOR radial. This mode includes the VOR arm, VOR capture, VOR trek, and VOR overstation submodes. The flight director automatically transitions between these submodes. The crew selects a VOR localizer as the navigation source and tunes to the desired frequency. In addition, a course must be selected on the flight guidance control panel. Normally, an intercept heading is also selected. The VOR mode is armed by pressing the nav push button, and the flight director goes into the heading select mode. When the aircraft reaches the intercept point, the flight director will automatically transition to the VOR capture, and finally, the VOR track mode. The VOR mode is deactivated by deselecting nav on the flight guidance control panel, selecting the approach or go-around mode, changing the air data computer or AHARS sources, selecting standby or horizontal situation indicator select, changing the selected nav source, activating any other lateral mode, or changing from the VOR frequency to a localizer frequency. Near the VOR station, the VOR deviation signal is unreliable and the flight director automatically transitions to the VOR overstation mode. In this mode, the flight director provides commands to maintain a heading equivalent to the selected course. As the aircraft goes further away from the station, the VOR deviation signal is reliable again, and the flight director automatically transitions to the VOR capture mode to capture the desired VOR radial. A selected course change does not exit the VOR overstation mode if that course change does not exceed 30 degrees. The VOR approach mode is similar to the VOR mode, except that it is used for an approach. This mode has the same submodes as the VOR mode. The localizer mode is used to track an ILS localizer beam. This mode has three submodes: localizer arm, localizer capture, and localizer track. The flight director automatically transitions between these three submodes. To use the localizer mode, the crew selects VOR localizer receiver as the navigation source and tunes a localizer frequency. A course is selected on the flight guidance control panel. This course is the localizer course depicted on the approach chart. An intercept heading is set on the flight guidance control panel. Pressing the nav button arms the localizer mode and engages the heading select mode. The localizer mode will also arm if approach is selected. The flight director automatically transitions to localizer capture mode from the localizer arm when the aircraft intercepts the desired ILS course. It will then automatically transition to the localizer track mode when the aircraft is turned onto the localizer beam. The localizer mode is disarmed by deselecting nav or approach after the glide slope mode is armed, by selecting the back course mode, by changing the air data computer or AHARS source, by selecting the go-around mode, selecting standby or horizontal situation indicator select, or by changing to a VOR frequency. The back course localizer mode functions the same way as the localizer mode. The flight director commands during the capture phase are limited to 30 degrees of roll attitude and 24 degrees of roll attitude in the track phase. The limits apply to the localizer mode and the back course mode. Rates of turn per second are plus or minus 7 degrees in capture and 5.5 in track. The LNAV mode acquires and holds a lateral flight path computed by the FMS. The LNAV mode is selected by selecting the FMS as the navigation source and pressing the nav button. The LNAV mode does not go through an armed phase. Instead, the FMS commands the aircraft to intercept the desired flight path when LNAV is initially engaged. In the LNAV mode, the flight director supplies steering commands to track the computed flight plan path. The LNAV mode is deactivated by deselecting nav, activating any other lateral mode, changing the air data computer or AHARS source, or selecting standby or horizontal situation indicator select. The combined lateral and vertical modes include the go-around mode, the ILS approach mode, the dual flight director submode, and an optional FMS approach mode. The go-around mode can be selected at any time. It is normally used to transition from an approach to a climb-out during a missed approach. The go-around mode is selected by pressing either of the two go-around switches located on the power levers. When go-around is selected, the autopilot disengages. The flight director commands 10 degrees of climb and wings level. All armed flight director modes automatically disarm. The go-around mode is deactivated by activating another vertical mode, engaging the autopilot or by selecting standby or horizontal situation indicator select, or changing the selected air data computer or AHARS source. Selecting a lateral flight director mode other than wings level does not deactivate the go-around mode. The ILS approach mode captures and tracks the ILS localizer and glide slope beams. Glide slope capture is inhibited until the lateral mode has transitioned to localizer capture or localizer track. The ILS approach mode is selected by selecting a VOR localizer receiver, tuning a localizer frequency, and selecting the intercept heading. the ILS course must also be dialed in the course selector. Pressing the approach push button arms the ILS approach mode. This automatically arms the localizer mode, engages the heading select mode, and arms the glide slope mode. The active vertical mode existing at the time the approach button is pushed remains active. If no vertical mode is active, then the pitch hold mode is activated. When the lateral mode has transitioned to localizer capture or localizer track, the flight director automatically transitions to glide slope capture from glide slope arm as the aircraft intercepts the desired ILS glide slope beam. Once established on the glide slope, the flight director will transition to the glide slope track mode. The glide slope mode is disarmed by disarming the localizer mode, operating the pitch thumb wheel, or selecting any other vertical mode. During an ILS approach, the flight director system operates in the dual flight director mode. In this mode, FGM-1 commands and enunciations are displayed on the pilot's primary flight display, and FGM-2 information is displayed on the co-pilot's primary flight display. The flight guidance modules use information from the air data computer sensors and the AHRS sensors. FGM-1 and FGM-2 process flight director commands using the same sensors, except in the dual flight director mode. In this case, the flight guidance modules use sensor input from their associated side. If the dual flight director mode is active, both the left and right arrows on either side of the horizontal situation indicator select push button are lit, and the horizontal situation indicator select push button is inoperative. An active dual flight director mode displays green dual flight director messages on each primary flight display. When not in the dual mode of operation, both flight guidance modules use the same side data as the primary flight display selection of sensors for the flight director. The primary flight display selections are determined by the horizontal situation indicator select push button and nav source selection switches located on the flight guidance control panel, the EFIS attitude heading source, and the EFIS air data computer source reversion switches. A failure of a required sensor input for an armed or active mode will automatically clear the flight director mode, and a message indicating the nature of the failure is displayed on the primary flight display. A sensor failure will prevent the crew from selecting a mode affected by that sensor, and the primary flight display will display a message. Except in the dual mode, a mismatch between sensors will not clear the flight mode, since both flight guidance modules are using information from their respective side. However, dual modes affected by the sensor failure will be cleared. Both flight guidance modules will process flight director commands with only one valid AHRS or air data computer input. However, the dual flight director mode does require two operational AHRS and air data computers. The tactile control steering system enables the pilots to modify flight director targets by pressing the tactile control steering switch on the control wheel and establishing the new target. In addition, the tactile control steering enables the pilot to momentarily override the autopilot without disengaging it. Select the tactile control steering by pressing the switch located on either control wheel. If the autopilot is engaged, the pitch and roll autopilot actuators automatically declutch and actuator monitoring is inhibited. Press the tactile control steering switch to continue. When the tactile control steering mode is active, the flight director command bars are removed from the primary flight display, and the target values of the active vertical mode are replaced with white dashes. Tactile control steering status is displayed on the primary flight display in white letters. If the autopilot is engaged, the tactile control steering indication replaces the autopilot status indication. When the tactile control steering mode is active, manual selection of a new vertical or lateral flight director mode is inhibited. However, automatic transitions from armed to capture mode and from capture modes to track modes are not inhibited. When the tactile control steering switch is released, the flight directors update the target values to those values that existed at the time the switch was released. The autopilot couples the flight director commands to the flight control surfaces using pitch and roll servos. The autopilot is engaged by pressing the autopilot push button on the flight guidance control panel. An autopilot engagement automatically engages the yaw damper. If a failure prevents the yaw damper from engaging or disengages the yaw damper, then the autopilot also disengages. Press the autopilot push button to engage the autopilot and yaw damper. The autopilot will engage if AHRS-1 and AHRS-2 are valid and in agreement, ADC-1 and ADC-2 are valid and in agreement, and the aircraft is airborne at an attitude within the limits for engagement. Selection of the manual pitch trim disconnect switch or the autopilot disengage switches prevents engagement. Autopilot engagement is indicated by the illumination of the two arrows on either side of the autopilot push button on the flight guidance control panel. The message Autopilot displays in green letters on the left upper side of the primary flight display. The autopilot is manually disengaged by pressing the autopilot or yaw damper push button on the flight guidance control panel, pressing an autopilot disengage switch on the control wheels, selecting go around with the power lever switches, or by operating manual pitch trim. Manual autopilot disengagement is indicated by an amber autopilot disengaged or autopilot yaw damper disengaged message on the primary flight display. The message is visible for 5 seconds. This message is not cancelled by pressing an autopilot disengage switch. A manual autopilot disengagement is also indicated by an aural tone which sounds for 1.5 seconds. This aural tone is not cancelled by pressing an autopilot disengage switch. The autopilot automatically disengages if AHARS 1 or AHARS 2 fails or they both disagree. Likewise, the autopilot will automatically disengage if ADC 1 or 2 fails or both disagree. Automatic autopilot disengagement is indicated by two red autopilot disengage warning lights located on the glare shield. The warning lights flash until acknowledged by the flight crew, then remain steady for 5 seconds. The autopilot disengage warning lights will not illuminate for a manual autopilot disengagement. Automatic autopilot disengagement is also indicated by amber flashing autopilot disengaged or autopilot yaw damper disengaged message on the primary flight display. The primary flight display message also flashes until acknowledged by the flight crew, then remains steady for 5 seconds. An automatic autopilot disengagement is accompanied by an aural tone which sounds continuously until acknowledged by the flight crew. The autopilot aural warning also sounds if the autopilot disengagement was caused by a failure of one of the two flight guidance module power sources. Automatic autopilot disengagement visual warnings are acknowledged using the autopilot disengage switches located on the control wheels. Autopilot engagement is inhibited while the autopilot disengagement visual warnings are active. For an automatic autopilot disengagement, the autopilot disengagement warnings require a reset prior to re-engaging the autopilot. When the autopilot is engaged, it commands pitch trim to reduce the mistrim control column force held by the autopilot pitch servo. This ensures that the pitch will not jerk when the autopilot is disengaged. Active tactile control steering use temporarily disables the autopilot pitch trim function. The autopilot pitch trim function operates at either high or low speed. The trim speed is high when the calibrated airspeed is below 180 knots and low anywhere above that. The high-speed trim provides the autopilot with control authority during flap extension or retraction, landing gear extension or retraction, accelerations and decelerations, or a combination of the above. The FCECU gives priority to manual pitch trim commands from the flight crew. When pitch trim is manually activated, while the autopilot is engaged, the autopilot will automatically disengage. If the autopilot pitch trim system fails from an input or output monitor, an amber autopilot pitch trim failure message is displayed on the primary flight display. The flight crew can engage the autopilot when the autopilot pitch trim system is inoperative, provided that the normal autopilot engagement criteria are met. An autopilot pitch trim system failure does not automatically disengage the autopilot. During autopilot engagement, each flight guidance module monitors the autopilot pitch servo torque. When the pitch servo torque exceeds a certain limit, the flight guidance modules will display an amber mistrim trim nose up or mistrim trim nose down message on the primary flight display. The pitch mistrim message is removed from the primary flight display when the autopilot pitch servo torque is reduced below the trigger limit. The pitch mistrim message is not set by the automatic flight control system when the autopilot is disengaged or when tactile control steering is active. The flap auto pitch trim system reduces the changes in control column force during flap movement. The system is active when the pilot is manually flying the aircraft. The auto flight control system transmits commands to the FCECU to control a pitch trim actuator that repositions the neutral position of the elevator control system. The flap auto pitch trim system commands nose down trim for flap extension and nose up trim for flap retraction. The flap auto pitch trim system computes the flap position rate from the flap position received from the flap position indicator unit or FPIU. The flap auto pitch trim function introduces nose up or nose down trim commands when the magnitude of the flap position rate is greater than a certain limit. Trim commands are discontinued when the magnitude of the flap position rate decreases below the threshold. The flap auto pitch trim automatically engages when the weight on wheels indicate that the aircraft has been airborne for 2 seconds, the calibrated airspeed is less than 180 knots, the autopilot is not engaged, the flight crew is not operating manual pitch trim, and when the automatic flight control system detects that the flaps are moving between flaps 15 and flaps 35 in either direction. The flap auto pitch trim automatically disengages when the aircraft is on the ground or the calibrated airspeed is greater than or equal to 180 knots. Engagement of the autopilot automatically disengages the flap auto pitch trim system. The system disengages when manual pitch trim is used or the automatic flight control system detects that the flaps are no longer moving. The flap auto pitch trim disengages automatically if the flap auto pitch trim function is commanding a pitch trim in excess of the trim limits. Indication of a flap auto pitch trim function failure is the appearance of an amber auto trim failure message on the primary flight display. There are no specific indications when the flap auto pitch trim function is disengaged or inhibited due to a pitch trim system failure detected by the FCECU. Instead, the pitch trim system failure is enunciated by a pitch trim fail light. The caution light pitch trim at the upper left on the caution light enunciator is the light used. Similarly, there is no specific enunciation displayed if the flap auto pitch trim function is disengaged or inhibited due to the selection of elevator trim off. During autopilot engagement, each flight guidance module monitors the autopilot roll servo torque. When the servo torque exceeds a certain limit, the flight guidance modules cause a display of an amber mistrim trim left wing down or mistrim trim right wing down to appear on the primary flight display. The roll mistrim message is removed when the roll servo torque is reduced below that limit. The autopilot does not disengage automatically when a roll mistrim occurs. The roll mistrim message indicates to the flight crew that the control wheel is mistrimmed and that there may be a significant control wheel jerk when the autopilot is disengaged. The yaw damper minimizes Dutch roll tendencies and coordinates turns. Mechanical stops limit yaw damper authority to a maximum of 4.5 degrees. Yaw damper commands are limited as a function of airspeed. The yaw damper can be engaged at any time, including when the aircraft is on the ground. However, yaw damper engagement is inhibited when the roll angle exceeds 45 degrees. The yaw damper is engaged by pressing the yaw damper push button on the flight guidance control panel or by pushing the autopilot push button. Autopilot disengagement does not disengage the yaw damper unless the disengagement was due to a failure, which also causes the yaw damper to disengage. A disengagement of the yaw damper automatically disengages the autopilot. The flight crew disengages the yaw damper by pressing the yaw damper push button on the flight guidance control panel. This push button is monitored to detect a stuck condition. The yaw damper automatically disengages if the yaw damper button is stuck. Press the yaw damper push button to continue. Yaw damper engagement is indicated by 2 illuminated arrows on either side of the yaw damper push button. These 2 arrows are extinguished when the yaw damper is disengaged. Automatic yaw damper disengagement is indicated by a flashing amber yaw damper disengage or autopilot yaw damper disengage message on the primary flight display. The primary flight display message flashes until acknowledged by the flight crew, then remains steady for 5 seconds. The flight crew acknowledges the yaw damper disengagement primary flight display message by using the autopilot disengage switches on either control wheel. Manual yaw damper disengagement is enunciated by an amber yaw damper disengage or autopilot yaw damper disengage message on the primary flight display. The message remains in view for 5 seconds. This message does not flash, nor is it cancelled by pressing an autopilot disengage switch. Yaw damper engagement is inhibited while the yaw damper disengage message is in view. The yaw damper inhibit message is displayed when yaw damper engagement is inhibited by the AHARS or Air Data Computer Monitoring System or when the aircraft attitude exceeds the engagement limits. If the flight crew tries to engage the yaw damper when the yaw damper engagement is inhibited by a source external to the automatic flight control system, the amber autopilot yaw damper failure message is displayed on the primary flight display. The yaw damper actuator is automatically recentered after the yaw damper is disengaged, either manually or by an external automatic flight control system fault. The yaw damper actuator is not automatically recentered following an automatic yaw damper disengagement due to an internal automatic flight control system failure.
If the yaw damper is not engaged and the yaw damper actuator is not centered, an amber yaw damper not centered message is displayed on the primary flight display. This concludes the Automatic Flight Control System module.